In this section of the course, I'm going to give you an introduction to the various sources of information at your disposal that you can use to understand what the forecast is telling you, and then interpret it in order to make more informed decisions on where to go and what to photograph. Naturally, the forecasts do get a little less accurate the further in advance you are looking, but in general, I'm looking 3 or 4 days in advance at a time, and then increasingly up to the evening before I plan to go anywhere in order to make any final decisions on locations. And setting off early gives you plenty of time to assess the weather conditions en route and make any last-minute changes of plans if required. Therefore, I'd always suggest having a backup location in mind. Now, looking at what information you have available, it can be very confusing simply based on the sheer volume of information and weather apps out there at our disposal. So on screen is a list of apps and desktop-based information we'll be looking at in this section and then referring back to through the following sections of this course as we delve into greater detail in respect to each weather condition and how this information can be used. Some of these apps are paid, but there are free versions available on the desktop browser, so please just check before you start downloading them. And it's worth noting here that a lot of these apps and web-based services are numerical models that are simplified versions of atmospheric phenomena, and as you can expect, particularly around mountains for example, they can get quite complex and difficult to get right. Ventasky is one of my favourite apps. This service provides a meteorological visual representation of data across the whole world. Therefore, if a hurricane happens in Florida, then it allows an illustration of the entire system and how it can impact us here in the UK or wherever you're based. The data is updated about every 6 hours, so it's perfect for checking most of the way up to leaving the front door. Windy is another app. It's a similar visual-based app, and in respect to this course, they can pretty much be used interchangeably. However, for the purpose of this course, I will only be looking at Ventasky.
So looking at the user interface, it breaks down various sets of data into layers which you can toggle on and off. We can also search our specific location from the top and set the time and date up to even 2 weeks ahead along the bar at the bottom. Although I must note forecasts that far in advance can be quite unreliable. On the right hand side you have a key or legend which gives you the units and measurements of which layer you are looking at. The data is also split up into a grid. I'm currently showing ground temperatures, and the closer you zoom in, the denser they become. So you really can get a good idea across the area you're looking at. We also have the moving streamlines, which are the wind directions. Wherever I was to toggle air pressures and zoom right out, you can see how the high and low pressure systems impact them. So the first layer is temperature. By default, it is set to 2 meters above ground level, which is about right for just above the heads of most people. It is worth noting that it cannot distinguish between the top of a mountain or city. Therefore, if you're interested in a temperature at the top of Snowdon, for example, you can understand that better by selecting the height closer to that. Having the option to understand change of temperature with height is one advantage of Ventasky, and this comes in useful when it comes to predicting cloud inversions, which we'll come on to later in this course. It is also useful being able to see localised changes in temperature, such as the cooling of a valley, and this again has an impact on various phenomena we'll discuss. You can also select freezing level, which can be very useful if you're up in the mountains and want to know if you'll get a good frost for your photos, or maybe even want to camp beneath the freezing level just to make your night camp that bit more comfortable. Perceived temperature considers the impact of sunshine, wind and humidity, which can in combination make you feel hotter or colder. I often use these layers to judge what clothing to wear. Precipitation is the next layer. You're able to toggle 1 hour or 3 hour predicted rainfalls, and then scroll through the chosen day to see how the rainfall develops. Looking at the wind streamlines also, you can understand the direction and intensity of rainfall. I'll often toggle this with the cloud coverage also, so I can get an idea of potential breaks in clouds for the sun to beam through, which obviously can give you dramatic light and atmosphere across a landscape, as well as potential for rainbows. The radar and satellite layers. These modes give you current intensities of rainfall and cloud coverages respectively. The radar function provides a coloured scale from light blue to red, with red being potentially not just heavy rain or snow, but also thunderstorms, hail, strong winds, or even tornadoes. Cloud cover. The outputs here show the percentages of cloud cover for low, medium, high, and total cloud covers. These are associated to ranges of heights of clouds, and this information is useful when we discuss predicting fire skies and rainbows later in this course. Low clouds can in general be attributed to rainfall and associated mood and drama, and medium high clouds often make for interesting sunsets. Absence of all clouds here is useful when it comes to large drops in temperature, which contribute to the formation of frost, mist, fog, and cloud inversions, and we cover all of these later in the course. Wind speeds and gusts. Now, as I mentioned earlier, the streamlines on the map show the wind directions, and we can toggle between average wind speeds and maximum gust speeds. Windy days are great for certain types of photography, and especially if you're out chasing rainbows, as it brings about rapidly changing weather conditions if accompanied by rain and breaks in the cloud. Again, we'll come on to this in more detail later in the course. In general, our prevailing winds here in the UK are from the southwest, or the westerlies, which you may have heard of, although more locally there are variations. However, if you're planning long distance hikes or cycle rides, for example, this can be a consideration in which way you complete your routes. After all, there's nothing worse than constantly walking into the wind. Air pressure. The graphics illustrate air pressure at sea level, and these differences in pressure are predominantly what influence wind speed. We'll discuss this influence later in the course. I often look at air pressure a week or two ahead of time, as this gives me a better understanding of what weather we may have coming. Low pressure is generally attributed to unstable conditions, such as spells of rain and winds, and high pressure being more stable, associated with a better, more consistent weather, often with clear skies. High pressure does lead to the most varying temperatures due to heating in the day and cooling during the clear nights, and this can be useful for various weather phenomena also, which we'll come on to later in the course. In the UK, we have constant battle for supremacy of 5 key air masses, which is why we have such changeable weather conditions. It's almost as though we don't have our own weather and we're simply borrowing it from somewhere else. Pressure systems can channel or funnel warm air masses from the south, or cold masses from the north, such as when we have rare and unseasonably cold or hot weather. This can be due to changes in pressure systems. Also, depending on whether this is coming from across the sea, that's the maritime air masses, or from land, that being the continental air masses. And this can dictate whether it will be hot and wet, hot and dry, cold and wet, or cold and dry. This also impacts how humid the air is, which has a significant role to play in the formation of mist, fog, and cloud inversions. Thunderstorms. If you're into lightning chasing, then this layer gives you various models of prediction of thunderstorms, and quite simply shows you the high levels of atmospheric instability where lightning is likely. With our southwesterly prevailing winds here in the UK, a great place to photograph the thunderstorms safely is along the south coast of England, such as if a thunderstorm passes out at sea, you have a clear line of sight out to it. Humidity and dew point layers. Humidity is the concentration of water vapour in the air as a percentage of the total amount it can hold at that temperature. As temperature decreases, the amount of water vapour it can hold reduces. And dew point is the temperature at which the air needs to be cooled in order for the humidity to reach 100%. At this point, vapour is forced out of the air as liquid and can lead to mist, fog, and cloud inversions, which we'll be discussing in the next sections of this course.
Waves. You can toggle between wave heights and types of waves here. Wind waves are what they say on the tin, created by the effect of wind on the sea surface. And swell waves are essentially old wind waves that change their name once they're no longer impacted by wind, and are generally created out at sea and move under their own momentum. The wave periods can also be viewed here, which is time in seconds between the top of the waves. For photography purposes, if you're interested in photographing coastal scenes with big crashing waves, then these layers, along with general high winds and gusts on the forecast, can give you a lot more detailed information. In this version of the course, we won't be looking at any more detail at waves.
Snow cover. This tab allows us to distinguish from precipitation. Although when we're looking at the rainfalls, snow is actually identified with a snowflake icon. This graphic does consider elevation and shows the depth of snow and anticipated new snowfall for a period. Air quality. This is a measure of several pollutants and dusts. And in general, I only use this when I'm photographing something from many kilometres away, as poor air quality can cause a haze, leading to reduced visibility. High pressure can lead to poor air quality, and therefore reduced visibility, and it tends to trap particles in the atmosphere. So looking at the air pressure in conjunction with the air quality tab is quite useful. At the bottom of the interface, we'll also have the option to select different weather models from across the world. These are different institutions from across the world that run complex equations based on the laws of physics on huge computers, using data obtained from weather stations and satellite. We have options for German, American, Canadian and other institutions, but in general I leave this on the German icon as it tends to be more reliable for Europe. Unless perhaps I've noticed something happening outside that doesn't quite tally with the forecast, I might occasionally toggle between these layers.
Fog. One final function that is actually hidden away in this app and is very useful is the fog map. This is located under the clouds layer. The fog map allows you to assess much larger areas for the likelihood and coverage of fog. Again, these aren't always entirely accurate and it doesn't quite distinguish between light mists and fog, with fog being the denser of the two and classified by range of visibility. If you can't see further than 1,000 meters, then it's fog. Otherwise, it's mist. This layer is great for cross-referencing across forecasts on different services and apps, and also to give you a broader look at the region in order to understand where to go.
So that gives you an introduction into Ventus.sky, but also what each of the sets of data tells you. We'll look at a few more apps and sources of information in this section. And then we'll come on to how to interpret this data later in this course. This next app, Clear Outside, is probably one of the most popular for photographers, and it provides tabulated hourly data up to several days in advance. Again, the accuracy of this does decrease the further in advance you look. Now, compared to Ventus.sky, it is a much more basic service, and despite its less user-friendly appeal, its advantage is it puts all the data in one place, making it simpler to assess for your specific location. Whereas Ventus.sky allows you to compare larger areas or regions more easily. Now, it's always worth cross-referencing data and readings across apps and services. A lot of them generally do use the same source data and simply represent it differently, but there can be clear differences at times. You can see that the layers we had on Ventus.sky are somewhat mostly represented here, with everything from low, medium and high cloud percentage coverage, all the way through to wind, fog, rain and temperature. So we're going to specifically go through each of these items again because they're representing pretty much the same information. However, one drawback of this service is that it does not give you a profile of temperature with elevation like you can get with Ventus.sky. This is quite important where in the next section we'll discuss cloud and temperature inversions, as it's important to understand whether one will form at all. Photopills and the Photographer's Ephemeris, or TPE for short. Both of these apps are absolute must-haves, particularly for photographers. These allow you to plan your photograph based on direction and elevation of the sun, moon, or even the Milky Way. However, just to note, we aren't covering night-based photography in this course, but if you're interested, there's a fantastic book by Alan Wallace called Photographing the Night Sky, which I would very much recommend. The app offers a satellite and topographic-based visual interface, which allows you to pin your planned location and understand the direction which the sun will be at for your chosen time. What is so fantastic about these apps, too, is that you can also plan your exact shot in advance in the planner function. You simply enter your camera, your focal length, your aspect ratio, and focus distance, which is usually the subject of your photo, and it will give you a visual representation of the width of your image. In general, I use Photopills, but can somewhat use both interchangeably. Photopills does have a huge bundle of additional features useful for photographers, and the user interface is visually much better, which is probably why it is the paid app in the first place. However, TPE does offer something Photopills does not, and that is an additional paid plugin for about £30 a year, and that is the Skyfire predictions. Fire skies we'll come on to later in this course, but essentially these are when the sun is just about to rise or is just set, and the orange glow of the sun is reflected off the underside of the clouds, hence the name Fire Sky or Skyfire. TPE assesses various sources of information to determine whether a fire sky is going to occur, and it gives you a visual-based representation of potential hotspots of it in a clear green, amber and red warnings, red being the strongest likelihood. This is a great little tool for easily assessing a larger region and to assist you in deciding where to go. We'll go into this in greater detail later in this course. Mountain Weather Information Service. This online-based service provides detailed reports daily from around 5 PM, and as the name suggests, is tailored towards mountain safety, and therefore it's specifically for mountainous or hill walking regions in the UK. The reports are written by meteorologists, and I often find these to be my final check before making a decision on where to go and what to photograph, and to verify what the other apps are telling me also. MWIS gives you a percentage chance of cloud-free tops, cloud-based levels and frost levels, and more specific to the region you are looking at. As you can imagine, a forecast that says fog in the valleys and cloud-free mountaintops can lead to quite the spectacle. I'll come on to this in more detail in next sections when we discuss cloud inversions. These can be a fantastic final check on weather conditions at a location, particularly for fog, snow and cloud inversions, but is entirely reliant on there being one available at or near your chosen location. Now there is a number of these available in various regions, but it can be quite random where they actually are located. What I would suggest here is having a Google search for webcams in your chosen region and keep a link of these saved, as they can be outside pubs, petrol stations or absolutely anywhere, so you have to do your homework here. Rain Today is a really simple service and one of my favourite apps. We'll come on to photographing rainbows later in this course. However, if you're doing so, then you'll need to keep an eye on the rain, and most importantly, the breaks in the rain, as you can miss a rainbow in a matter of moments. So my go-to app for this is Rain Today. This provides live satellite-based data of rain up to an hour in advance, but in general, I'd trust it for around 30 minutes ahead of time based on my experience. It also gives you the direction of the rain it'll be coming from, and graphs of its intensity and duration. I tend to use this when I'm out in the field, provided I have signal, so I can have my compositions ready. So that concludes this introduction into the apps and web-based sources of information I would use for predicting the weather from forecast data. It can be a little overwhelming with all this information, so I suggest you have a play around with these apps and web-based services first, not only whilst you're sat at home studying the forecast, but also when you're outdoors, as linking what you are seeing and feeling to what the forecast actually says builds that experience and cements understanding. In the following sections, we'll go into greater detail about how various weather phenomena occur, and delve into more detail about how these apps are used to support you in witnessing and capturing something spectacular.